So I've got monochlorooctane. So I've got octane, so C8, and it would be, if it's an ane, then you double the 8 to add 16, add 2 will be 18. Except one of the 18 hydrogens, so it's C8H18, but one of the 18 hydrogens has been replaced by a Cl. The chlorine contains the isotope 35Cl, so it could be a 35Cl or it could be a 37Cl. However, it's in the ratio for every 1.5 of these, there's one of these. So it's in the ratio 1.5 to 1. But if I multiply it by 2, it's in the ratio 3 to 2. So, if it's in the ratio 3 to 2, 3 35s for every 2 37s, for every 5 of these, if I have 5 of these, 3 of these, and 2 of these, I'd have that one, and that one. So it doesn't matter where the Cl is, it doesn't matter where it is on the molecule, then the Mr is going to be the same in this one with a 35, this one with a 35, and this one with a 35, and this one with a Cl, and this one with a Cl. So 3 times out of the 5, 3 occasions out of the 5, it's got a 35 Cl in, and 2 occasions out of the 5, it's got a 37 Cl in. You add up the masses of everything, so you've got 8 carbons in everything, so 8 times 5 multiplied by 12 for a carbon, 17 times 5 times 1 for a hydrogen, and then you've got a 35 and a 35 and a 35, 3 35s and 2 37s, gives, when you add it up, a total mass of 744. To work out an average, you divide by 5, that's the number of molecules that they are, and it comes out as 148.8. Isooctane reacts with excess chlorine to form a mixture of chlorinated compounds. One of these compounds contains 25.6% carbon, 2.56 hydrogen by mass. Calculate the molecular formula of this compound. So, what have I got in there? I've got carbon, hydrogen. It also tells me that I've got some chlorine in there as well. The relative atomic mass of chlorine is 35.5. It's got isotopes, that's why it's an odd number, but it's 35.5. So I can work out if I've got 24.6% carbon, 2.56% hydrogen, then 100% take away 24.6, take away 2.56. I've got 72.84% chlorine in there. I divide by the relative atomic mass of each of them. So 24.6 divided by 12, 2.56 divided by 1, and 72.84 divided by 35.5 gives me the ratio of the number of atoms, 2.05 to 2.56 to multiply by 2.05. I divide by the smallest, so I divide by 2.05. That's always the way that I solve this. So it's 1 to 2.56 divided by 2.05 to 1, 1 to 1.249 to 1. I'm looking for a number that I can multiply this by to get it up to a whole number. If I multiply it by 8, it equals 10. So 8 ones are 8, 8 1.249 is a 10, 8 ones are 8, so I'll multiply through by a number and I have C8H10Cl8. That's the molecular formula.